Welcome back to another CAD-CAM tutorial. In this video, we are going to start with sheet metal modeling because I received a lot of comments to start sheet metal tutorials. So this is what we are going to start. We are going to start with this simple model, and in the subsequent videos, we move on to more complex sheet metal models. Now, I want to apologize because I have not been uploading tutorials recently. That's because I had an exam to write, so it's made everything tight. But fortunately, I am done, and we are going to be uploading more tutorials from now going forward. This is a drawing or a draft file for the sheet metal part. This is the top view, and then this is the front view. So we have two section views showing this first section here, and then this section CC showing this second section here. All the dimensions are in millimeters. The material thickness is 3 millimeters, which is the thickness of the sheet metal, and the bend radius is 3 millimeters. So most of the time, the bend radius should be equal to the material thickness. This is all we need. So this is a very simple model. Make sure you watch the video to the end, and please like the video, subscribe, and turn on post notification so that you get the notification anytime I upload a video. And make sure you share the video to your friends as well, so they can also watch the sheet metal modeling tutorial. Now you can ask any question you have in the comment section, and I'll reply you and help you in any way I can. Now let's begin. We are inside the Siemens NX window. We can now start. So create a new file. Set the template to sheet metal and then the unit millimeters. Specify a name for the part and a folder to save it. So in the desktop, I'll save it in the NX export file. Okay. And then when you click OK, it takes you to the sheet metal modeling workspace. So this is it. You have all these commands for the sheet metal. You can see it's different as compared to the modeling workspace. You have these commands we are going to use. So let's start. So before you start any sheet metal modeling, first have to select a part on the model that will be your base part. So we are going to use the middle part here as the base. So a rectangle of length 100 and a width of a certain width value which we are going to calculate, and that will be the base. Then we attach any other parts to it. So for the base, we use the tab feature, which creates a base feature. Sketch section. This is similar to the modeling. If you're using extrude, you go to sketch section to sketch a profile to extrude. The same way, you go to tab and then you create a sketch. Select the plane. Okay. Now draw a rectangle with the from center method and the center on the origin. The length of the rectangle is 100 because looking at the top view, the full length here is 100. And then looking at this section CC, the radius of this arc is 30. So the diameter, which will be the full height or the full length here, is 30 times 2, which will be 60 millimeters. And that will be the width of the rectangle. So a length of 100 and a width of 60 millimeters. Sketch is fully constrained. You make sure every sketch is fully constrained before we convert to 3D. So finish sketch. Material thickness 3 millimeters. Okay. Then we attach this feature to it. So this is a flange feature. So we use a flange which adds a flat flange at an angle to a planar surface. So we first have to select an edge. So we go with this edge. This is the top view of it. Now we specify the width option as full. We have the center and other options, but we go with full. And then the length of this flange here is 50 millimeters. Now the 50 millimeters starts at this edge here. So length 50, the angle 90 degrees. The length reference, where should the length start measuring? We have the inside option, which will start here. But looking at the dimension here, the length, which is the 50 millimeters, starts at the edge here. So set the length reference to outside. Material insert, where should the flange be with respect to the tab we created? So we can have material inside, which will be inside this tab. So the last edges of both the tab and the flange will coincide or will be in the same line. Or material outside, so the flange will come here. Or bend outside, where the bend will start at the end of the tab. So we need the material inside. Offset 0. The bend radius, as we saw, is 3 millimeters. Now when you come to preference, and it's sheet metal, you can see the bend radius here. You can set it predefined, and the material thickness as well. Okay. Now we can cut out these shapes from it. We are going to use the normal cutout sketch section on this face. So we need this O-brown feature. So profile tool, we need a horizontal line, an arc, another horizontal line, and we close out the shape. And then we need 4 circles of diameter 6 millimeters. Let's dimension the O-brown feature. The horizontal line has a length of 30 and the radius of the arc is 5. The distance from the start of the O-brown feature to the end here is 25. Then we make sure these 2 circles, the centers are horizontally aligned, same for these circles. And then these 2 circles also have their centers vertically aligned, same for these 2 sets of circles as well. So click on the 2 centers here, horizontal alignment. Again, these 2 centers, horizontal alignment. Now these 2 centers, vertical. And these 2 centers, vertical as well. So the distance between these 2 centers is 20, and the distance from this center to the end is 30. The distance between the centers here is 40 millimeters, and make sure that the centers are symmetric about a midpoint. And then from this center to the midpoint here should be half of the 40, which will be 20 millimeters. So now the sketch is fully constrained. Finish. The cut method, material thickness, limit until next. Okay. We have a chamfer here of dimension 10 millimeters. So we use the break corner feature, the method chamfer, a distance of 10 millimeters, and then select this edge. Okay. Next, we add this flange as well. So with the flange feature, and then you select this edge, a full flange, and then the length is 60 millimeters, again starting from this edge. A 90-degree angle, and the length reference should be outside to start from this edge. Insert material inside. Everything here should be maintained. Okay. Then you round in this corner with a radius of 30. So again, we use the break corner, and this time you blend similar to the edge blend, a radius of 30 millimeters. You can click on these two edges or just click on this face to round in these two edges. Okay. Again, you use the normal cutout to cut out these circles or these holes. Normal cutout, sketch section on this face. Okay. So draw a bigger circle of diameter 20 and smaller circles of diameters 8. The bigger circle should be on the center of this arc. So locate the center point of the arc. Circle of diameter 20. And smaller circles of diameters 8. Now you're going to align the centers horizontally and vertically, and the distance between these two centers horizontally 25, vertically 35, and they are symmetric about the midpoint. Horizontal alignment as well. Horizontal alignment. Now give this a vertical alignment and this as well. The distance between these two centers 25, and in these two centers 35. We make them symmetric about the midpoint here. So make symmetric the primary object this center, secondary object this center, and the center line should be this vertical axis. Again, we change this symmetry center line, deselect all, and this time the primary object should be this center, secondary object this center, the center line should be the horizontal axis here. And you can see sketch is fully constrained. Finish. Cut method, thickness and the limit until next. Okay. Next, you cut out these shapes as well. So again, normal cutout, sketch section on this face. Okay. We need two center lines, a vertical one and a horizontal one. Click on the lines and make them reference lines so they do not form part of our cut. We are just going to use them as mirror references. And then we sketch this first O-brown feature. So horizontal line, an arc, another horizontal line, and an arc to close out the shape. Make sure this line is horizontal. And the length of the horizontal line is 15, the radius of the arc 5, and the distance of this point to the center is 15. Then we make sure the O-brown feature is in the middle. So click on this point, which is the midpoint of the O-brown feature, and then click on this center line here, point on curve. Sketch is fully constrained. Then we mirror onto the other side with the mirror curve. Select connected curves and then click on this line. Center line should be the vertical line. Okay. Then we make this cut. So an arc by 3 points. The first point here, second point here, third point somewhere here. Then we close out the shape. The vertical distance of the arc is 8. So from this point to this line is 8 millimeters. And then we make sure that the center of the arc is in the middle. So click on the center, click on this center line, point on curve. The radius of the arc 30. Sketch is fully constrained. Again, we mirror, select connected curves, click on this arc to select the full shape. The center line is this horizontal line. Okay. Finish sketch. Again, material thickness until next. Okay. So this will be it. And then we come to view, show hide, we hide all, and then display only solid bodies. Then we change the material appearance, come to true shading, the global materials. We're going to use the shiny metal wash. Okay, so we use this brushed metal wash. This is okay. And give it an isometric view. So yeah, that's how to create this sheet metal model using Siemens NX. This is the end of the tutorial. I hope this video helped you out. Feel free to go back and watch the video again to fully understand the concept of sheet metal modeling using the tab and the flange and then the normal cutouts. I'll see you in the next tutorial. Safe.